Welcome to Bungalows for Bachelors number 16. Today we're going to talk about doors and windows and hopefully learn some things in house wrap, and waterproofing is also part of that. So let's get right into it here. So still in phase 3, we're making a building enclosure. We got the foundation, we got the framing, we got a waterproof roof. What's the next thing? Well, we'd like to waterproof our walls. So doors and windows is going to be the main next step in that journey. So I shouldn't have to ask this, but you never know, who knows what. So what are doors? Well, they are methods of entering and exiting the environmental boundary of your house. We have doors instead of doorways and openings so that we can, close off the space that's inside our house to the space that's outside our house. And, they swing and we can open them and stuff. So that's what they're for. And what are windows? Well, windows are the elements of your wall or roof, because you can have skylights up on your roof. It's basically a window that allow light and or temporary airflow, like ventilation. You want to let your house breathe, to pass through your wall assembly. So same basic principle, except most of the time they're not for going through with a body. They're just letting light or heat or air through. So what is the purpose of doors and windows? Well, like I was talking about before, entrance and exit. Now, this is particularly important if you have emergencies and there's a fire and you can't get to the front door. Well, then you can use a window as an exit if you need to, like in the picture on the right, fire escapes, right? It's a safety thing. So windows can be used, and they are intended for that purpose sometimes, depending on where you're placing them. But otherwise, they allow the natural environment into the home. So in the photo on the left, this house would be much more plain and not as exciting if that all those walls were just walls, no windows, right? You wouldn't get to see that ocean view or island view or whatever they got going on there, right? It wouldn't be that nice. So we add these windows and doors to let light in and also to see the outside environment, right? We're trying to still have our own inside separate environment, but we want to be able to see the outside if it's something that adds value and something that makes us happier in our little home. Now that can also be light, and heat. If you're in a colder climate and you want to gain that solar energy, then you're going to want more windows to capture the heat, let it through the walls. And of course, if your house is relatively airtight and you want to like vent some fresh air in there, not that your HVAC would already be doing that, but you could open windows to let some big, nice breezes blow through your house if you wanted that kind of thing. So, quick little tidbit in here. When you're installing windows and doors, the first thing you got to have is a waterproofing membrane on the outside of your house. So either house wrap, or if you got zip system, all your seams have been taped, or if you have any other systems like zip system that are generally waterproof coated sheathing, you want to tape your seams. You want this house to be waterproof on the walls, staple that stuff up, tape all the seams where you need them. And then once you've got that done, you're going to go back over those openings. You can cut those holes in the openings where your openings need to be for your windows and doors. And then you're going to tape, add flashings, sill pans, things like that to waterproof the window openings, the door openings, so that water is not going to be a problem before you insert the window or door unit itself. And then once that's done, you're going to go back over the outside and you're going to seal up anything on the outside as needed to keep water from penetrating that opening. So what are some types of doors? We're talking about exterior doors for now. We're not going to talk about interior doors. The only core type you're going to see is a solid core. There are other types of cores, like a hollow core or like a foam core, where there's other ways to basically make a door less expensive and less soundproof, less thermally efficient. And that's just not going to fly for the exterior. So there are going to be solid doors. The exception to that is like a garage door in the bottom photo. There is, like, most of the time, if you buy a cheap one, it's just going to be a metal tin. But you can have insulation added to the backs of those. They can be foam insulated cores, stuff like that. So, and of course, a glass sliding door is going to be just the glass panes and whatever argon or whatever is between the panes. But first, the regular hinging doors, solid core. So opening style, you're going to have a hinged door, which is just that. It's going to have hinges on the side of the door and it's going to swing. You're going to have sliding doors. An example shown on the far right photo where the glass door slides. It's become very popular these days for the living space to have access to a back patio or something through a large sliding patio door that has maybe 4 or 5 panes of glass, and they all slide out of the way, so you can get basically an exterior interior mixture there. And then of course garage overhead doors, where they do what most garage doors do, where they fold and roll up overhead into the ceiling area. So what are some types of windows? Well, there's on the far left, what you see is a fixed glass window. The basic premise here is that you are not going to ever need to operate this window. You don't need it for fire safety. You don't need it for airflow. You just want glass, and they are the most air leak efficient because they are literally sealed shut. You're not going to have like brush seals or bulb seals or anything needing to be operated and seal things off. It's just permanently sealed. So most efficient in that regard. And they're going to have single or double hung windows like shown in the middle. And that's basically where, if it's a single hung window, usually the bottom half of the window can be pulled up and there's a screen or something to let air flow in through the window. A double hung window is the same thing, except the top can also move down depending on which way you want to ventilate for different reasons. Casement windows, you can have single, double, triple casement up, keep going past that if you want, but the basic premise is in the bottom right photo. They are doors that will they're windows that will hinge like a door, where the hinges are on the sides of the window. They can swing out, they can swing in, but that's the basic premise, is they're going to swing. Sometimes they're free swinging, and sometimes they're controlled by a little crank arm with a gear. Just depends on what kind to buy. Awning and hopper windows are the same premise as the casement window, but they've changed the location of the hinge. An awning window, the hinge is on the top of the window. When you push it out, it will swing up. And that basically is good for letting air in during bad weather areas where you got a lot of rain, maybe. The rain's going to come down, hit the awning window, and come off. And you can still get airflow while it's raining, even though the window is open. And then a hopper window is the opposite of that. And you might ask, well, why would you put a hinge on the bottom and then let the window open such that rain would come into the house? Well, that you don't want to open it in the rain. But I think the main application that I've seen this in is basement windows, where you've got a window right above ground level and you need to be able to open this thing and kick it out so that you can maybe escape. But they're not very common. But they're called hopper windows. And then there's sliding windows, which is like a sliding door, just smaller, and it's up in your wall. You can slide your pane left or the right, and that's how those work. General guidance for doors and windows. So this is sort of talking about design, thinking about what you might want in a project or in your house if you're doing some construction. And the two standard heights are 80-inch and 8-foot for door heights. You can get custom special doors outside of those ranges, but those are pretty much standard. Now, if you're going to have a ceiling that's 10 feet or taller, then you probably should not use an 80-inch door. You're welcome to do, of course, whatever you like, but typical design guidance is that the door will look too short on that wall. It will look kind of dwarf size, so you wouldn't want to do that. And if you're going to end up beefing up to an 8-foot tall door, then you are also going to want to scale up the width of the door. That way your doors don't look tall and skinny. So if you typically would have had like a 30-inch by 80-inch door for a bedroom access in a regular house with an 8-foot ceiling, and you got a 10-foot ceiling, then you might use a 32-inch wide or a 34-inch wide. It's pretty straightforward. They start at most of the time 24 inches, and they go up in 2-inch increments, door sizes up to 36. So that's what you would do if you were getting some taller doors. You'd scale up that width so it looks reasonable. If you're looking for a wheelchair accessible width, the number is 32 inches if you're worried about that. Most typical bedrooms access size for furniture and things like that is 30-inch. And if you've had a particularly hard time in your life with furniture and bedrooms, then just make it wider. Typical minimum closet or bathroom access size is going to be a 24-inch door. That's pretty much the smallest you can go and comfortably just walk in shoulder to shoulder, no problems. They do feel a little bit tight, but they can save money on a large scale. Now, one of the things I would like to talk about with respect to the sliding doors is those wide patio doors I was mentioning. These doors can be sometimes, 10, 12, 14, 16, 18, 20 feet wide, massive sliding glass patio doors, right? These doors, because they take up so much wall and they're not contributing any lateral strength to the wall that they're in, and it's on an exterior wall where lateral strength has to be, then you run into problems with shear wall design, and we'll talk about lateral, we'll talk about the house design, structural stuff later. But the basic premise is, if you're going to use one of those doors, you have to pay extra close attention to how you're supporting that wall laterally so you don't have any problems. And then for windows, if you got bedrooms, just keep in mind, bedrooms and living areas they got a egress requirement. So if you have one window in your bedroom, it must meet that requirement so that you can get out. And that's all listed in the code. Egress means escape, to fire escape, to need to emergency escape. That's what the egress requirements are. And low sill height for fall safety or breaking glass. If I go back to this fixed glass window up here on the left, top left photo, see how the glass is all the way down by the floor? That means that is a very low sill height. The sill is the bottom of the window. So there is a risk that someone might roll something across the floor, or they might kick the window with their foot, or they might step backward and their heel could kick it and break it. So there are special requirements for windows with low sill heights, especially if outside the building is very high up from the ground. So you got to pay attention to some of those requirements, and those are things you can find online, but that is something to pay attention to with windows. And that matters because if you need to, basically, if that sill is low, you are required to have a special tempered glass, which just makes it more expensive. So just keep in mind, okay, am I going to be willing to pay the extra for this extra long window? Maybe, maybe not. Thermal ratings. So we rate the thermal efficiency of doors and windows sort of the same way. Doors are basically mostly wood usually, but they can have metals, but they have windows in them normally, so they're kind of in the same category. So U factor is just the inverse of R value, and R value is just a descriptor of how good something is at resisting the transfer of heat conducting through the material. So insulations like fiberglass in a wall would be like an R13. Well, you wouldn't do this, but the U factor of that would just be 1/13, and it would give you some number. So the U factor is referring to how much heat is going to radiate through this glass window. And that is improved by adding more panes and putting inert gases in between the panes like argon. So the typical range is from 0.2 to 1.2, but that just kind of gives you an idea of, okay, if I buy this window from Home Depot and the number is like a 1.2, then it's probably not very good. And because it's an inverse of the R value, and the higher the R value, the better it is insulation. Well, the higher the R value, the higher the U factor, the worse it is at insulating for glass. So that's all the number means. And then solar heat gain coefficient, this is usually just written out as SHGC. You will find these specifications for whatever window product you're buying. Usually it's a sticker on the window if you don't see it there, but you can find it in descriptions online and stuff like that. But it ranges from 0 to 1, and it represents the amount of energy that's going to be passed through the glass. So if it was a 1, then you would have effectively no glass. It would be blocked. Like you had a brick wall. No solar heat is going to pass through that thing because it's opaque. Now, if it was a 0, then that would be like you basically don't have any glass, so the glass is perfectly clear. There's going to be no reflection. All of the sunlight is going to go right through the glass into whatever is behind the glass, and it's going to heat up that, and it's going to heat up the house. So solar heat gain coefficient is talking about how efficient is that glass at keeping the sunlight, at filtering out the sunlight effectively, not like shade-wise, but in terms of energy. So we have some rough drawings here of some assemblies of a door and a window. So on the door, what you're seeing is the wall framing around the door, and you're seeing the door's jamb and the door slab itself. So the header and the jack stud are just pieces of framing that are going to frame the opening for a door before you put it in. And assuming a pre-hung door here, which is just already has its jamb and its hinges and its slab and its hardware, it's all assembled already. You would basically just slide it into this thing, put some shims between the jambs and the jack stud in usually three places, top, middle, and bottom. Same on the hinge side, top, middle, and bottom. If you have a 4-hinge door, then you would put a shim behind each hinge because the hinge is where you're going to screw through the shim. And then you are going, or at least close to it for a good support. And then you are going to basically, put everything, plumb and level it as you put it in, make sure the shims are gapping everything right, and then you're going to nail it, screw it in, and the jam will be secured to the jack studs and the king studs next to those around it. And that's what secures the door in place. And the threshold on the bottom is usually attached if it's a pre-hung door, and it just kind of lets the water shed out away from the house when the water hits the door and runs down. It's got a little seal on it. So that is generally how a door is assembled into a wall. And the window photo, which is not super helpful, but it gives you the basic idea, is you're going to have some kind of waterproofing layer or something on the outside of the house. You are going to take the window unit. Usually it doesn't really depend on what kind of way it opens. It's just the window unit. And it's going to be put into the hole and into the opening on the wall. You're going to have some spacers. Usually you set down on the sill to kind of space the window up so it's not just sitting on the wood by itself. To place it vertically evenly in its place. And then there's going to be this nailing fin or nailing flange that goes around the window where you will put some nails in around that. You don't want to fill every single hole, but you want to, use a decent number of them so that the window's not going anywhere. So that's how a window is installed. They're usually a little more simple. In situations where you have renovation stuff going on, like brick or other places where you can't, like you got siding on and you don't want to mess things up, then there are different styles of securement and mounting of windows. Some windows will have strips, like a reveal strip on the outside that comes out temporarily so you can screw it into the wall. And then they put a strip back in and you can't see the screw heads. Some of them have screws that go through the jambs, through the side into the studs. So there's multiple ways to mount a window, but most of the time in new construction, that's what you're going to be dealing with. It's just a fin on the outside that's got a bunch of holes in it and you're just going to put some nails in. So if you want to learn more about doors and windows, there's tons more to learn. I basically just summarized what they're for, how they work, stuff like that. But you ought to watch the YouTube Spec House series, episode 80 by Central Craftsman, where he talks about getting his windows installed in the Spec House. And then if you want to know about some of the requirements for how to deal with windows, how to select them, or what to think about when you're thinking about windows, read IRC 2021 R303.9, R308, and R310. When it's referring to glazing, it's just referring to glass, which is windows. So it's got fancy words for everything. If you see the word fenestration pop up anywhere, it's referring to openings or perforations in your wall assembly. The fenestration, that's what that means. I think I might have had that on a slide earlier, but that's what that means. So just fancy words in the code. And then you should watch YouTube video Windows 101 Window Styles by MI Windows and Doors to get an idea for just what some of these window styles look like. And watch These Passive House Rated Doors / Windows Are Bomber by Matt Risinger, because he talks a lot about window ratings and why they are so important when you have a lot of them in the house to keep a house thermally efficient. So that is all for BFB number 16. We'll see you on the next one.